Okay, guys, just want to go over lesson 4.3. By the end of lesson 4.3, you want to be able to make a prediction by using the equation of a line that closely fits a set of data. All right, to go over this with you, I'm going to go ahead and do the try-its with you through the book, and then we'll also go over the do you understand and do you know. Looking ahead here on page 224 under try it, assuming the trend shown in the graph continues, use the equation of the trend line to predict the average fuel consumption in miles per gallon in 2025. Okay, so we got a nice trend line here. Let's go ahead and make note of that. Our trend line starts here at the y-intercept and runs right up through the dots. We got a real strong relationship there, strong positive relationship. A lot of the dots are right close to the line, so I got a pretty good idea what this is going to look like. Okay, so the equation of the trend line is what I got to find, and this is nothing new. This is things we've been doing for a very, very long time here. I'm going to pick 2 points on the line, so I'm going to go here, and let's say here at 20. I'm going to draw a right triangle, connecting the 2 points, and I'm going to count the rise over the run. Now, the rise over the run, all right, my rise is 6, so I'll go ahead and move that down here. All right, and my run here is going to be 20. Now, of course, 6 over 20 is going to simplify to 3 over 10, so that's my slope. My rise is 6, my run is 20, therefore 3 over 10. So let's go ahead and put that in here. All right, my y-intercept is where that line starts at the y-origin. It's a starting point. So I'm going to say that's going to be right in this general area at 15. All right, so go ahead and write that in. All right, so we got 3/10 x plus 15. In 2025, the average fuel consumption is predicted to be about, All right, so if I look at the graph here, I notice that it's years after 1980. The question's asking, what's the fuel consumption like in 2025? 2025 is 45 years after 1980. All right. Well, that's going to be right here on the graph. And if you notice, my trend line doesn't go up that far. So what I'm going to have to do is I'm going to have to plug in 45 for x. So y is equal to 3/10 times 45 plus 15. And when you do all the math and punch that into your calculator, you end up with 28.5. Jump over to page 225, you come to the next try it problem. Okay, and example 3 goes over using a scatter plot and a linear relationship, a linear model between the temperature and number of smoothies purchased in thousands. Okay, the slope represents the rate of change, describes the number of smoothies purchased for each degree of temperature increase. And this is in thousands, guys. It's a big chain here. All right, y-intercept is what it represents when it's 0 degrees. And we have an equation there. All right, the try it problem says that a smoothie cafe has the ingredients needed to make 50,000 smoothies on a day when the high temperature is expected to reach 90 degrees. Should the cafe employees expect to have enough ingredients for the day's smoothie sales? Explain. Okay, now, how to do this is really, really, really complicated. All right, pay attention. You might miss something here. I'm going to go to 90 on the original graph. X equals 90, 90 degrees. And I'm going to go straight up. And that's going to tell me, the trend line will tell me roughly how many smoothies I can expect to sell on a 90-degree day. And if you're looking, that's going to come in right there at about 62,000. So no, the employees aren't going to have enough on a 90-degree day. Time on the do you know and do you understand. Number 1, how do linear models help you make a prediction? Again, we can find these answers at the top of the page. I'll go ahead and type in a sample response here. Scatter plots and trend lines can You fill in the blank. All right, you may want to say something along the lines of scatter plots and trend lines can help us predict future values. Rates of change and starting points can give us linear equations to solve for unknowns. Anything like that would be effective for that particular answer. Okay, down here, model with math. All right, how do you find the equation of a linear model when you are given the graph, but not the equation? Here we go. We pick 2 points on the line, on the trend line, I'm sorry. Count their eyes over the run. Find the starting point or y-intercept. Turn the numbers we found into y equals mx plus b. Can't make that a little smaller for you. There we go. It's not tripping over itself. All right, down to number 3. Can the linear model set for a set of data that is presented in a scatter plot always be used to make a prediction about any x value? I'm going to let you answer that one on your own, but think like outliers, clusters, things like that we've talked about previously in the chapter. That should maybe enter your thinking a little bit there. Come up to number 4. The graph shows a family's grocery expenses based on the number of children in the family. All right, so using the slope, predict the difference in the amount spent on groceries between a family with 5 children and a family with 2 children. Well, okay. Let's go ahead and get our drawing tools up and running here. All right, so I'm going to go ahead and use number of children here. This would be here at 2, so okay. Going to be right in this general ballpark. And a family of 5 children is going to be here. And it wants to know the difference between the two. All right, so that 2, okay. Let's see. You're going to be right around 120. All right, whereas at 5, you're going to be right around 190. Okay, so you could probably estimate, and it says predict the difference. You could say between $60 and $70 and be okay there. All right. Sorry about that. All right, so part B, how many children can you predict a family has if the amount spent on groceries per week is $169.47? Okay, on this one, we've got to use the equation because it's giving us a very specific amount here. We can do some math here. All right, so let's set this bad boy up. All right, so 169.47 is going to be equal to, I'm not going to have enough room here, 21.08 plus 85.15. Let's come down here where I have room. Sorry about that. Okay, I just work that equation through. As I'm working through, get all the way to the end, I work it out, and I'm left with x is equal to 4. Let's come up and check the chart here. All right, at x equals 4, I'm right there about halfway between 140 and 210. So yeah, that would make sense. All right, guys. Good luck. Take care of yourself. There are other assignments involved. I know you guys have a Math Excel, and if you're in Schaefer's class, you have a math quiz on this. So good luck. Take care of yourselves, and I hope to see you soon.